there's a protocol, a software protocol between miners and pools called Stratum that's been around for over 10 years.
Just to clarify, the thing that you just mentioned is a risk to decentralization, right? Because the miners are acting rationally to pool their risk with others, but then whoever controls the pool becomes a centralized point, and I think a big risk to the network overall.
That's correct. For multiple reasons. With the current Stratum protocol, Stratum V1, the entities that are choosing the transactions that go into a block are the pools. Mm-hmm. The miners themselves are just kind of like a dumb participant, literally just calculating SHA-256 hashes over and over and over again. And they're just being told by the pool, here are the transactions that we want to put in this block. Now calculate this magic lottery, this magic number that'll win the lottery. So that's one big problem today within Bitcoin and with the Stratum V1 protocol. There are many other problems with the Stratum V1 protocol. The actual wire protocol itself has no encryption, no authentication, and it's like JSON. It's a very inefficient. It's like basically plain text. It's very inefficient protocol between the pool and the miner. Because if you think about what kind of communication has to go back and forth between the two, the pool needs to keep sending jobs to the miner saying like, anytime the pool is going to be running a Bitcoin Core node, it'll continually be receiving new transactions that people want to mine. And anytime there's a transaction it receives any given second that has a high fee rate, then it's going to want to insert that into the block it's trying to mine. It has to keep, but then the pool needs to keep communicating to all the miners of this updated block template to mine the transactions. So there's a lot of information shared to the miner. Then the miners need to be communicating back to the pool constantly with proof that it's actually mining for that pool. Because imagine if you're a miner, what prevents you from mining, telling every pool in existence, oh, I'm mining for you, pay me out
Right.
when you win a block. Well, if you tell every pool that, then every block found, you're going to get paid. So there has to be some kind of system there which demonstrates that you're actually mining towards that pool's block template. So Stratum does have a system to solve that, but there's a lot of communication back and forth. So what we're presenting here on the screen is a study that was just released within the past week or so, comparing Stratum V2 to Stratum V1 performance. Because unlike Stratum V1, Stratum V2 solves the problems I just mentioned. It adds encryption, it adds authentication. It's a binary protocol, so it's a much more efficient wired protocol. And for decentralization, the most important thing is that it allows miners themselves construct block templates and choose transactions that go into a block.
Yeah, that's big.
So it's a major, major upgrade. It's been in the work for many years. Spiral has contributed a lot to it, but many mining companies have as well. There's an open source reference implementation for Stratum V2 that's had contribution from Foundry, which is one of the biggest pools in the world, contributions from Brains, which is a really popular mining company, Hut 8, Galaxy, and many other organizations. So it's a true public good, but we're still not seeing adoption of Stratum V2. So this study was put together where benchmark data was created to compare, the performance improvements of the wire protocol. Does it actually matter? Is it just some nerd engineer thing, or does it actually matter to the business economics for the mining pool? And the headline here is that you can improve profitability by 7%.
That's huge
with Stratum V2. So is that just like made up, or like what's the substance behind that? So we're going to walk through this. So this first graph here, let's see. Can you scroll up Yeah.
Are we looking at acceptance rate?
Yeah. So share acceptance rate. Yeah. Okay. Thank you. So yeah, back to the graph. So what is this? Well, as I mentioned earlier, the miner has to keep sending what's called shares to the pool, which is proving that, I'm actually applying hash rate to the block you're telling me to mine. That's what a share is, and that's what this is. Now, so the miner keeps sending this to the pool.
And what is that share? Like, is it a signed message, or like with some private key, or?
It actually has to have some proof of work with it.
Oh, interesting.
So you don't have to achieve the difficulty level of actually mining the block.
Yeah.
Because obviously that means you mined a block.
Yeah.
But so it's a weaker difficulty, but it proves that the hash rate is applied to the block that pool is set out to do, not another block.
Cool.
So it's a proof of that.
And how often do you have to keep sending those?
It varies, but think on the order of like 10 to 60 seconds. Like I think 30 seconds is pretty common, but that's the order of magnitude.
Cool.
Most of them are valid shares, but you can have invalid shares too. What's an invalid share? Well, it's a share that is too late. So too late meaning like in between the time that the miner sent that share to the pool, another block has already been mined. And so the miner was no longer doing work towards the tip of the chain. So it's just wasted energy.
From whose perspective? From the mining pool, from their node's perspective?
Yeah.
Okay.
So assuming the pool would receive a block from the network.
Yeah.
It believes it to be the tip of the network. It did advance it one block.
Yeah.
Of course, that can be reorged out, but for the most of the time it's true. It doesn't get reorged out, and then the pool then would just throw away that share and not. I mean, the purpose of the shares here is accounting. It's so that the pool knows how to pay out to the miners, like because when the pool does win a block or when the pool does a payout, it has to know how much to pay each miner that's connected to that pool, and any of these shares that are stale, it'll throw them away and not count them. So as a miner, that's bad. You want to achieve 100% of your shares to be accepted. So what this graph here is showing is that with Stratum V1 on this benchmark study that was done, and it should be noted it's a simulation that was done, so not the real network. So that should be noted. But I think it's a pretty high quality simulation of reality. And it's a little hard for us to see, but hopefully the audience can read those numbers better. But the bottom line is Stratum V1 has something like 0.1 to 0.2% loss for these stale shares. When you add in Stratum V2, it drops substantially. The losses drop substantially. And then there's two different Stratum V2 options here. One is where the pool still selects the transactions. So for people looking at the display right now, JD stands for job declaration. And that's sort of like who's declaring the block template, who's declaring what the transactions are. So if the pool it still is a big win. But if the miner actually selects transactions, it's an even bigger win. It basically goes to 100% accepted shares. So if you can eliminate 0.2% share loss for a miner that has, say, 10% profit margin, this can be a 2% boost to your profits.
Yeah, wow.
So, so you can take these like latency numbers and share loss numbers, translate them into real dollars and cents.
Now, high level, how much of this is just because Stratum V2 is more efficient, so you're doing binary instead of JSON, versus how much of the benefit comes if the miner is the one doing the block template selection?
That's the two scenarios. So so in this graph, it's the Stratum V2 without job JD.
Okay. Oh, got it.
That's where you're getting the benefit from the wire protocol efficiencies.
Got it. Okay.
And then Stratum V2 with JD, that's where the miner itself is selecting transactions. That's when you get both the wire protocol and the miner is selecting the transactions.
That's beautiful because then the economic incentive for decentralization.
Exactly. So that's what got me really excited about this, because it's not just like an ethos sales argument. Because like if you're telling the miner, hey, you gotta run your own Bitcoin core node, and then the miner's like, oh, it's more operational hassle for me, and it's like, well, do it for the ethos. It's like, okay. But now it can be like, well, no, actually, if you can boost your profitability by like 1.2%,
that's huge.
It's huge. And over time, margins are going to continue to be compressed, and so an extra 1 or 2% profit margin will be enormous. It'll separate the winners from the losers.